How's it going, everybody? And welcome back to our Cisco Enterprise series. I wanted to share a little bit of info about EVE and a problem that I was encountering before we dive into the technical content for today's video, or this video, I should say. So one of my goals was to have Wireshark available to us as we are going through all of our technical examples and walkthroughs and stuff like that, because there are going to be times where we're going to want to see how the traffic patterns, you go point A to point B and stuff like that, so we understand how the protocol stack works and things like that, and look at some of the details that would be easier to look in a Wireshark output than it would be for me to try to draw it out in a whiteboard session. So one of the issues that I ran into, which I've fixed, and I wanted to share that with you, was I wanted to be able to do a capture. So if you right click on any device and you go to capture and you select the interface that you want to capture. This is EVE Pro, so it'll run Wireshark inside of EVE. So what should end up happening is when you click on that, it should automatically launch this guacamole, a Docker instance, and then we're going to choose the Ethernet interface to capture on. That's the only thing that's supported as far as I know. And we're going to start seeing some spanning tree going back and forth. So I can scroll, I should be able to zoom in on this and then make it a little bit bigger. Yeah, so we'll zoom in on this so you guys can see what's happening. And we'll be able to expand out. We'll be able to see spanning tree protocol and all that type of stuff. So this will help with you guys understanding the details behind the scenes. Well, this wasn't working. I couldn't get it to work. I kept on erroring out and whatnot. So I did some research, and then I was in the EVE-NG cookbook as I Googled the problem. I literally Googled EVE-NG Pro Wireshark not working. And so I got a link to the EVE-NG Professional Cookbook. So I went to the EVE-NG Professional Cookbook, and I got to here, and I scrolled down a little bit, and it was, where was it? Right up here. It says it wasn't a troubleshooting step necessarily. I just happened to look up Wireshark, and it said Docker instances. So you're using Docker reinstall update to fix or install or fix Docker stations in EVE Pro. You run DC images on the CLI, and when I did that, you're supposed to get a bunch of these little outputs. When I did that, let me scroll up to where I started. I ran the command and I got nothing back. Literally, I got crickets. I was like, oh, well, that's not good. So then I looked at this command. It says apt install reinstall EVE-NG dockers. I ran that command. It takes some time, and some of these files are pretty sizable. But then when it was fully redeployed, I was like, okay, cool. So it installed these repositories, these instances, and then as soon as I did that, now Wireshark pulls up for me. So in case you guys are running into problems, and I wanted to cover that before I got into any of the details of how this could be broken or what have you. So one of the things to keep in the back of your mind when you're looking at the operations of the network. So with that being said, that is what I want to talk about for that. And the reason why I'm doing this is because I'm going to, I can click this little button right here to be hide console. So it'll go down here in the bottom left. I'm going to right click here, capture, and I gig 0/0. Because we're going to set up trunking in this video and get that all configured. So click OK there. So now that we've covered that, I'm going to go ahead and pull up capture on gig 00. Oh, I already did that. So I've got these two here, and until we need it, I'm going to go ahead and just minimize so they're out of the way, and if I need to, all I have to do is just bring it back up like that, and then minimize it again. I think it'll actually go and do a transparent mode as well. Yeah, so you can see where you're going through, so it'll go transparent as well, in case you were wondering about that. And if you wanted to, you can go full screen with it as well. So pretty cool capability there. And as you can see, nothing really going on. So I'm going to go ahead and just hide that for the time being. So the next thing we're going to have to go do is I'm going to pull up let me go to my downloads and pull up the blueprint for CCIE Enterprise Infrastructure. Swing this guy over. And what we're going to do is we're going to set up 802.1q trunks, or a trunk, and goodbye. Set that up here on gig 00 and on both switches and get that going. And what we're going to go do with that is I'm going to explain the concept of DTP, Dynamic Trunking Protocol, and how that can be used to be both a dynamically negotiate an 802.1q trunk and then statically set it. So let me go ahead and pull out my pen tool here. That's hiding. Yes, I want to do that. So as that's pulling up, Dynamic Trunking Protocol is a way for switches to negotiate what protocol is going to be used for the trunk. So there are two different trunking mechanisms that Cisco Catalyst switches support, and that's ISL, Interswitch Link, and then 802.1q. ISL is the Cisco proprietary version and is a full encapsulation of the traffic. It didn't take off. Not to be confused with the ISL capability when you're dealing with storage networking on Nexus switches and you're dealing with VSANs. Not the same thing. So if you happen to see that also correlate, it is not the same concept. It's something different. So the way that DTP works at a high level and simplicity is there's a negotiation process that goes back and forth between the switches. And let me go bump this up to medium. So by default, the switch ports are in the mode of dynamic desirable. So what dynamic desirable basically means is this. I am going to try to negotiate this over and over and over again. I'm going to try to be a trunk. It wants to be a trunk out of the gate. So if both sides are dynamic desirable, then what will end up happening is neither one of them will be able to make a decision. Be this, be this, be this, be this. So what we need to do instead, let me go ahead and pull up the CLI here and scoot this guy over. And you scoot this down just a touch. So on switch 6, if I click inside of here and I do this, I do a show interface gig 0/0 switch port. It is in the, I'm sorry, I take that back. I always forget that it's dynamic auto. So dynamic auto as the switch, the administrative mode means that it is going to attempt to negotiate, it's going to wait for somebody else to tell it what to do. So I take that back. They are not in dynamic desirable, they're in dynamic auto. So because they're in dynamic auto, they're waiting for something to be told to them. So we're looking at gig 0/0, and it's in dynamic auto, and the operational mode is static access. The administrative trunking encapsulation is negotiate. DTP is what that means. So DTP is not a command per se. It's not like spanning tree. We're talking about a negotiation that's going back and forth. And if we pull up this guy, we're going to see that you're going to see right here, dynamic trunking protocol. And it's seeing that DTP is version 1, the trunk status is access auto, and the trunk type is ISL negotiated. Sender ID is going to be switch 5. So that tracks with what I just said, right? So what we're going to go do is we're going to tell switch 6 we're going to that is going to be a trunk link without configuring switch 6. How are we going to pull that off? We're going to go on switch 5. We're going to go ahead and statically configure one side. So from a logical perspective, you're always going to want to configure the upstream side the distribution side of your layer 2 environment, that is where you're going to make your changes. So the distribution side will always be a static configuration. So switch port trunk encapsulation 8.1q will be the command. And then the access side, or the logical downstream, that will be dynamic. You don't have to do it that way. Literally every environment I've ever worked in, we always go with static on both ends. So we, set the trunk mode appropriately. So I'm actually going to let this go through and do its thing. And I'm going to say here, and I'm going to say apply as filter selected. So what we're going to go ahead and see, actually take that, I meant to do DTP. Apply as filter, remove filter. And then we're going to click on this guy. It moves every time I try to do that. Apply as filter selected. There we go. So what I'm going to go do is on switch 5, my goal is to have this stuff magically show up. I'm going to go ahead and get out of the way while we're doing this so you guys can see all this. And let me go ahead and blow this up. So that it's easier to see, and I can bring this piece up just a little bit. So let's do this. I'm going to go to global config. I'm going to type in host name is going to be switch 5, and then interface gig 0/0. I'm going to type in here switch port trunk encapsulation .1q. So we're going to see some information go back and forth. So we see this come through. And that's a CDP connection. And then we're going to go back to here, and then we're going to say switch port trunk, switch port mode is going to be trunk. Okay, so now DTP is going back and forth. It's setting all this information. Now it's 802.1q, and it's setting to negotiate. So right, we see trunk is on. We change the operational mode to that. To 802.1q. Now if we go to switch 6 and we go back and we look at this again, you'll notice that it's still dynamic auto. The operational mode is trunk. It's negotiate, but now the trunk encapsulation is .1q, right? Instead of before it was native, which is ISL. It's .1q, and if I go on this side here and I type in do show interface trunk, we're going to see that the mode is on. The encapsulation is 802.1q and the status is trunking. If I jump over to switch 6 and I do the same thing, I do a show interface trunk, you'll see that it's auto, so it's still in the mode of auto, dynamic auto. We can verify that right here. But if you look right here where it says N dash, means it's negotiate. But if you look on this side here, it's static. If I do show interface gig 0/0 switch port, you'll see that the operational mode is trunk. We've hard coded it to be a trunk port. The mode is trunk. The administrative trunk encapsulation is .1q. The operational trunk encapsulation is .1q. Those don't line up on these sides. So here we have dynamic auto. The operational mode is trunk because we negotiated it. The administrative trunking encapsulation, negotiate. So it's still negotiating. So switch 5 is statically set. Switch 6 is dynamically learning it. That's where we have this N-802.1q there. So that's where that piece comes into play. Now, in this particular case, we're squared away. Now, would I recommend staying like that? I wouldn't. No. I would recommend hard coding it on both ends unless you have a very, very, very dynamic environment where you're constantly pulling switches out and putting them back in and you're not worried about the configuration. But still, you would still do it. I mean, there's really I can't even give you a legit use case. It's there, know how that works, but beyond that, I can't think of a legitimate reason why I wouldn't go forward and set both ends of it to be static. So let's go ahead and do that real quick. So I'm going to go to global config, interface, gig 0/0, switch port, trunk and cap.1q, switch port mode of trunk. So now we come back over here, we're going to see that it's trunk on 802.1q, 802.1q versus what it was here where it's 802.1q on one side, negotiated on the other. So one side is saying, I'm saying I am, the operating is .1q, the administrative type is negotiated. So if I go back over here and I type in do show interface gig 0/0 switch port, you'll notice that the operational mode and the administrative trunk encapsulation, it's trunk and .1q. That's the piece that I want you guys to pay attention to. So beyond that, that is the basics to what it is that I want you guys to understand. If I pull up switch 5 doesn't have a whole lot going on. I actually might need to close this out and relaunch it on 5. So let me go ahead and close that out and minimize this. So that is how that comes into play and what you should be aware of when it comes to how all that stuff works. Now what I'm going to go do is I'm going to go over to switch 5 and I'm going to go ahead and do show VLAN brief. All of my ports right now are inside of VLAN 1. I have 1002, 3, 4, and 5. You've got FIDI default, token ring, FIDI net default, token ring net default. These are active but unsupported VLANs. No one ever uses them. So what I'm going to go do is on switch 6, I'm going to look at what VLAN IDs I have. So do show interface trunk. I need to have, and then I can do show VLAN brief. I have 310 is LAN, 311 is Wi-Fi, 313 is VoIP, and 314 is servers. So that's what that is configured as for those are the VLANs. And then we can see I might have to move, let me do show run interface gig 0/1, 311. Okay, I screwed up there. I need to make that actually 313. But what I'm going to go do is I'm going to take these 4 VLANs right here and I'm going to go create them on switch 5. So I'm going to type in VLAN 311, or sorry, 310. The name will be LAN. 311 will be Wi-Fi. 313 will be VoIP. And 314 will be servers. Okay, now that I've done that, and the VLANs have been created, show VLAN brief. The VLANs have been created, and if I do a show interface trunk, you'll see that the VLANs are going to eventually be added to the spanning tree. They're all active in the domain, but not quite all there for forwarding. So in case you don't know what that means, we'll get into more of this when we get into spanning tree. And this goes back to that manual VLAN pruning thing I was talking about. What ends up happening is we end up having all the VLANs are active and allowed in the management domain, and then all VLANs are allowed across the trunk. However, currently, until I update this, when I run the command the show interface trunk again, only VLAN 310 is allowed to be forwarding state on all trunk interfaces and not be pruned off. So if I hit the up arrow again, all of them will be there now. And now if I do a show MAC address table dynamic, you'll notice nothing is there. And if I go to switch 6, do a show MAC address table dynamic, I am learning traffic from gig 01 and gig 02, but nothing on switch 5. So if I go to PC48 and I ping 172.31.0.67, I can ping across. Switch 6 is learning that. And if I look at switch 5, now all of a sudden I'm learning that traffic. And the reason why I did that is because I have there needs to be active traffic in the network in order for MAC address propagation to work. So if I go back over here to switch 6, there's going to be, let me go ahead and clear this out real quick. If I look at, there should have been a update, spanning tree. There should have been a MAC advertisement, and I forget which one of those it's going to be. There's a lot of traffic going back and forth. But it would have pushed, maybe it's PVST. Well, that's just a bridge identifier, spanning tree. So there should have been a big push. DTP. Nope, that's not it. So there was a MAC push. I'd have to go through each one of these individually and figure out which one it was that pushed all the MAC addresses. But one of these breakdowns in Wireshark would have shown the MAC addresses being pushed from switch 6 to switch 5, so that switch 5 could learn them. Now that switch 5 has them, if switch 5 has a device attached to it, like R23 and R24, for example, then he would have been able to, R24 would be able to talk to PC48 once it's up and running. We're not quite there yet. I wanted to talk about how the trunking piece comes into play and how that operates. But at a very basic level, that's what you need. So just to recap the commands we applied here, if I go ahead and get out of the way, if I do a show run interface gig 0/0, all I did was specify the trunking encapsulation first. And as a quick side note, on Catalyst switches, and I don't know how new the version of code is, but the rule of thumb that I've always used, because I've seen it bark at me a bunch of times, is if you have a scenario where you are going to create a trunk link and you set the mode first on a Catalyst switch, it'll bark at you and tell you you can't set the mode until you have set the encapsulation. Because by default, it's you have to remove it from being an access port. So you can't put tagging, encapsulation tagging, on an access port. Because if you go back over here, if we do the show interface status, or show interface gig 0/0 switch port, notice how it's now negotiation of trunking. If we go back in time here a little bit, it should have been, it was set to dynamic auto as the administrative mode. And now we are, once we did our configuration and went to trunk, and if we scroll back even further, notice how the operational mode was static access. If you do this out of the gate, it is going to squawk at you and say, hey, you have to, you can't do that. Now you might ask, why does it go static access? Well, the reason why it goes static access is because it's been sending DTP frames out of the switch port, and there's spanning tree involved in that, and it's not detecting another switch. So if it doesn't detect another switch, based off of what it's seeing, it's automatically going to think it's an endpoint. And to accommodate that, it's going to default it to static access. So that is why it is set up that way. If you were to pre-configure, you're going to add a switch to an environment, let's say, and you were to pre-configure the interface that's going to be attached to that switch port. Let me give you a visual. If I was to add switch 7, right, and then run a link to here on gig 0/4. Well, let's say choose gig 0/1. If I was to say on gig 0/1, if I was to pre-configure gig 0/1 with the command switch port trunk encap.1q and switch port mode trunk out of the gate, and then add switch 7 on, say, gig 0/0, what would end up happening is this process right here that you saw when we first started wouldn't even happen, because it would automatically detect that there's a switch attached to it, and then you would get that N-802.1q would get applied, and you would automatically become a trunk link. But you have to pre-configure it in order for that to work. You can't have two interfaces attached to a switch, and this is a switch and this is a switch, and both of them be in dynamic auto here and here, because dynamic auto is saying, tell me what you want me to do. Tell me what you want me to do. And if both sides are saying, tell me what you want me to do, nothing ever gets done. So you need one side to be a desirable, or I want you to be like this. Go do this, go do this, go do this. So until you cross that line and do that, you're not going to get the dynamic piece to do what you want it to do. And that's the basics to that, how that process works. So hopefully that answers your question and fulfills some information that you may not have already known about. So that is basically what it is that I want you guys to be aware of in this particular case. So fairly straightforward process, but it definitely requires some understanding if you don't already know what's going on. So now that we've covered that, the last thing that I want to talk about is going to be the native VLAN, because we're literally right here. We might as well talk about it because it's right here, and we can see that, right? We can see that the native VLAN is in place, and if we look at the root identifier, we can see that the root bridge priority 32768, which is the default value, right? 32768 all the time. The root bridge system ID extension, VLAN 1, and then the system ID, the actual MAC address of the switch. Well, if you look at the next one, a couple down, you can see that it is 32768. The system ID extension is 311, which when you actually add these two together, it comes out, this would be like 40,000 and change, or just under 33,000. So that's the bridge information, right? So what I would end up doing if I wanted to affect who's the root bridge is I would just modify the priority. You move the priority around, you can change who the root bridge is going to be. Now if I was to come back over here and do a show spanning tree, and I'm getting ahead of myself here, but even though the switch is enabled for rapid spanning tree protocol, and the root bridge is saying is 5, and that would make sense because 5 numerically is lower than 6, right? So the root port in this particular case is gig 0/0, which is my connected interface to switch 5. Now if I look, that's VLAN 1, but if I look at spanning tree, show spanning tree for VLAN 310, for example, you'll notice that my priority here is 33,078, right? And that's the thing I was just talking about a moment ago. The system ID extension and the priority are added together, and then that becomes your priority value. Again, the MAC address doesn't ever change, right? So since the MAC doesn't change, you have to affect it by priority. So, but you can see here, this is VLAN 1, and it's across the board. VLAN 1 is also our native VLAN. So if I was to do this, let me go over here to switch 6. I'm going to change the native VLAN to be VLAN 314. So I'm going to go say interface gig 0/0. I'm going to type in switch port trunk, and then native VLAN is going to be 314. Now what's going to end up happening is we're going to have, it's going to scream at us. Let's go down here. And after, you can see it's telling us that there's going to be a problem. It went way too fast. So let me go back over here to this guy. Switch 5, now it's starting to squawk at us. CDP is squawking at us saying, there's a native VLAN mismatch. Native VLAN mismatch discovered on gig 0/0/314 with switch 5 of VLAN 1. Right? Let me stop this capture. Actually, I saw it when it triggered. So that's DTP. And it's going to continue to do that. CDP is telling me that there is so native VLAN is 314, right? That's a bad thing. I don't want that to be VLAN 314 on one side and VLAN 1 on the other. So that we have to go fix. So in order to fix that, we're going to go on to, and now switch 5 is squawking at us. Switch 5 says that we are VLAN 1 on gig 00, but switch 6 is telling me he's 314, so we need to go fix that. In order to fix that, we're going to go do show interface trunk, and we can see the native VLAN is 1. I'm going to come in here and say interface gig 0/0, switch port trunk native VLAN 314. Okay, now that that's been adjusted, we go back to switch 6. We're no longer going to get that squawk, and we're in good shape. So now we see all these messages going back and forth. If we click right there, now we can see that it is 314, and everything looks good. And so that is the information that you are curious about and how it works. So with that being said, let me go do this. Let's do a show interface gig 0/0. And so what's interesting about Wireshark is if you find any of those CDP alerts, I might as well just, there's a every 60 seconds is the hello for those. So if I look at CDP, it's telling me that if I come down here a little bit, that the VTP, the native VLAN right here, the duplex is half. So duplex is half. So if I went over to here, if I look at this, it's auto duplex auto speed. But if I do a show interface status, it's telling me that where duplex is auto. So this is one of those situations where it's software, it's not a physical switch. So I'm not really that concerned whether or not it's that or not full duplex or not. But I can set that. I'm going to go to interface gig 0/0. I'm going to say the duplex is full. It says auto negotiation enabled. Duplex cannot be set. So in order to fix the duplex, if you want to hard code your interfaces, you would type in the command no negotiation auto, and then you type in duplex full, and do the same thing on this side. You go type in no negotiation auto, and then duplex full. So what will end up happening is we'll get a CDP alert, and then if we go back over here and do show interface status, we should see that, yeah, see it's still saying that it's auto. Let's click on this guy real quick. Oh, it went by so fast. Yes, the duplex is still auto. So even though I've set it, do show run interface gig 0/0, even though I've set it to duplex full, it doesn't matter. So in that particular case, it is what it is. I'm not too worried about it. It's a virtual environment. I'm not worried about whether or not it's duplex. That was DTP, not CDP. There's CDP. So if I come down here a little bit, duplex. Okay, now it's seeing as duplex full. However, the show interface status is not associating with that, which is fine. But as long as Wireshark sees it, I'm a happy camper with that. So that, ladies and gentlemen, is trunking. There's really not a whole lot to it. I went through a lot more detail than I normally would, just so you guys could see the overall effect of how it works. So that is pretty much what you need to know about that trunking in order for everything to get working. So as we get further along and we get into these bigger environments, we've looked at access ports, we've looked at trunk ports, we've looked at native VLAN. We've also looked at the normal range VLANs and the voice VLAN. So what's next? We have two left. We have manual VLAN pruning and then extended range VLANs. I am going to move up to this environment here so that we can see how manual VLAN pruning would work. I could theoretically do it on this switch down here and then prune it off, but that's I feel like we're going to get more bang for our buck up here. And then we're also going to talk about VTP as well, because we're going to have two servers, and we'll talk about how that comes into play as well. So with that being said, if you guys have any questions for me, do put those questions down in the comment section below. If you like what you saw and want to support the channel, I definitely appreciate any type of support that I can get. So please like, share, and subscribe, and I'll catch all of you fine people in the next video. Have a good one, everybody.